für Stück für Stück für Stück.
If you've already worked with vinyl, you know that these films are extremely flexible, but there are limits. The example of this bumper shows that the deformations can be extreme. That is to say, we have to stretch the film heavily to wrap this component. But what is the limit? How far can you stretch a film, a PVC? In theory, a PVC film can be stretched by over 100%. But this does not mean that on a vehicle we can add 100%, because there is a risk that the film shrinks back in the areas with the greatest deformation. For this reason, we have to respect certain limits. The limit for a film applied on a vehicle is at 30%. A wrap with anything over 30% will come with a risk of failure. So, how are we going to measure this recessed area? By how many percent do we really have to stretch the film? To find out, we need a couple of pieces of tape that we are going to stick over the area we are looking at by bridging the recessed area. Then we mark the limits, which is not in contact with the surface, here and there, and this gives us the length of material available to us to stretch the film. Then we lift the tape off on one side, and we stick it into the recess. Then we mark the tape again at the limits of the concave area. This way we get the exact length we need to wrap the recessed area. Thus, we are able to measure exactly by how many percent of elongation we need, and we do exactly the same thing in the vertical direction. We mark again the limits of the free material. We lift it off on one side, and then stick the tape again into the concave area as before. And again, put marks on the limits. To remove the tape, and now we can make two measurements. We have here the two measurements that we just took, the vertical and the horizontal one. Now, let's start with the measurements. How much elongation can we really achieve? First, the horizontal direction. Here is the amount at our disposal. That makes 18 centimeters. 18 centimeters. Then the amount we need to stretch the film. 4 centimeters. Now, we have to divide 4 by 18, and that gives us the percentage. Here, an elongation of 22%. 22%, that's good. It's doable. We can go up to 30%, so 22%, that's very good. Now we're going to measure the vertical direction.
12
We have 12 centimeters from here to there. Then we measure the elongation. 6 centimeters. 6 divided by 12, that still gives us an elongation of 50%. 50% of elongation, for us that means way over the limit of the film. We have 30% at our disposal, but we need 50%. So in this area, we have to find a way around it. It's not possible to apply the film permanently in a single piece. Another trick would be to cut a relief to take away some tension, to use the potential of the film in the concave area. We can do the same demonstration on this door. Here we have a concave area into which we have to apply the film, so we have to measure our percentage in the same way. Once again, we take our tape, we stick it over the distance at our disposal, and again, we mark the two ends of the material at our disposal.
Des zur Verfügung freien stehenden Materials, lösen das Tape.
Then we lift the tape off,
kleben es durch die Vertiefung hindurch.
And we stick it on again into the recess, and with the second mark we can see the elongation we need to do this concave area. We're going to stick on a second piece of tape. To illustrate a different way of applying the film. Most of the time we apply the film in this way, by simply moving forward little by little, until we almost reach the end. Then, with a little heat, we still move forward a little. And this gives me material from here to here. We lift the tape off again and stick it into the recessed area. And then, we can see the elongation we need. In fact, we need exactly the elongation as before, but we have much less material at our disposal. This is to say, in percentage terms, the elongation is considerably higher. Now we're going to measure our tapes. Here on the left, we have roughly 8 centimeters at our disposal. And we have an elongation of approximately 0.5 centimeters. We divide 0.5 by 8. We do the same calculation on this side. We get about 2 centimeters with the same elongation of 0.5 centimeters. 0.5 divided by 8 gives us an elongation of 6%. No problem. 0.5 divided by 2, however, gives us an elongation of 25%. This is not really problematic, but it's obvious that with 2 different ways of applying the film, we're going to more or less stress on the material we have at our disposal. These are some of the basics of wrapping we need to understand.